The geometric distribution is a distribution of the number of trials needed to get the first success in repeated Bernoulli trials. Recall that Bernoulli trials are probability experiments that satisfy the following properties. There are exactly two possible outcomes in each trial, success or failure. The probability of success, P, is the same in every trial, and the trials are independent, meaning that the knowledge of one trial's outcome does not provide any information about the outcome of another trial. Let's go over the notation we'll be using. P is the probability of a success in any trial, and Q is the probability of failure in any trial. Since the outcome of each trial must be either a success or a failure, success and failure are complements. As a result, the sum of the probability of success and the probability of failure must equal 1. Since we know this, we know that the probability of failure, Q, is equal to 1 minus P. X is a random variable representing the number of trials needed to get the first success. Since it's a random variable, we write X as a capital letter. Now let's figure out how to find the probability that the X trial is the first success. We'll write this probability as P of uppercase X equals lowercase x, representing the probability that random variable uppercase X is equal to some specific value lowercase x. In order for the X trial to be the first success, all trials before the X trial must be failures. The number of trials before the X trial is X minus 1. Remember that the probability of multiple independent events all occurring is equal to the product of the probabilities of each separate event. Therefore, since the trials are independent and the probability of failure in each trial is Q, the probability that the first X minus 1 trials are failures is equal to Q raised to the power X minus 1. Next, the X trials must be a success. The probability that the X trial is a success is P, so we multiply by P. We now have our formula for the probability that it takes X trials to get the first success, which is the probability density function for the geometric distribution. The number of trials has to be a whole number, so this is a discrete probability distribution. There must be at least one trial to get a success, and there's no upper limit to the number of trials it could take to get the first success. So this is defined for the values 1, 2, 3, and so on. Let's try an example that makes use of the geometric distribution. At a large grocery store, 20% of people who visit a booth offering free food samples decide to take the sampled food item. Assume that all decisions are independent. What is the probability that the fourth person to visit to the booth is the first person to take the sampled food item? To begin, let's make sure that it's appropriate for us to use the geometric distribution. Each trial has exactly two possible outcomes. Either the person decides to take the sampled food item or decides not to. Since we're interested in the first person to take the sampled food item, we'll call a decision to take the item a success and call a decision to not take the item a failure. We're told that 20% of people who visit the booth decide to take the item, and we're told to assume that all decisions are independent. So the probability of success is the same in every trial, and the trials are independent. Therefore, these are Bernoulli trials, and we can use the geometric distribution. Recall that our formula for the probability density function of the geometric distribution is P of uppercase X equals lowercase x equals Q to the X minus 1 times P. 20% of people who visit the booth decide to take the item, so our probability of success, P, is 0.2, which is simply 20% expressed as a decimal. The probability of failure, Q, is equal to 1 minus P. Substituting P equals 0.2, we find that Q equals 0.8. We want to find the probability that the fourth person to visit to the booth is the first person to take the sampled food item. So we want to find the probability that the random variable x is equal to 4. Substituting these values into our formula, we get P of x equals 4 equals 0.8 to the 4 minus 1 times 0.2. Evaluating this expression, we get an answer of 0.1024. Therefore, the probability that the fourth person to visit to the booth is the first person to take the sampled food item is 0.1024.